Sorry that there is a phone call interrupt the video recording. So we continue. This represents the probability of p x3 equals to 0 given x1 equals to 0. And like so on, what we need is p x3 equals to 1 given x1 equals to 0. It is obvious this. So p x1 equals to 0 given x3 equals to 1 is 0.52 multiply 0.2 divided 0.592 equals to 0.176. And the last question asks us to find the n signal equals to 0's probability while n is infinity. So suppose we have remember what we did to figure out the probability of x2 equals to 0. We use the probability of x1 equals to 0 and x1 equals to 1, multiply the multiply this matrix, and we get the two probability of p x2 equals to 0 and p x2 equals to 1, and we use this to multiple this matrix again, and we'll get p x3 equals to 0 and p x3 equals to 1, and from so on we will get p xn equals to 0 and p xn equals to 1. So when n goes to infinity, I think these two values of two probability will converges to a specific value. So suppose the first one is A and the second one is B, and we'll have AB multiply this matrix. We'll still get AB, right? So we need to find the solution of A and B, and there one more condition: A plus B equals to 1. So 0.6 multiply A plus 0.3 multiply 1 minus A equals to A, and we get A equals to 3/7, and 1 minus A equals to 4/7. That's what we need to find, and that is p x n equals to 0 while n goes to infinity is 3/7.